Okay, here we are back. Just math, y'all. It's just math. You can do it. You can do it. So we're doing Cal 1. We are doing section 2-4, infinite limits. Here we are today. We are going all the way down to some more examples. This is the second video. All right, we're going to do some more examples of limits as when we plug in or we try to plug in, we get 0 and we have to analyze these. So let's think these through. So here's the first example using a sine function. We haven't done a whole lot of examples with trig functions, but I thought maybe this one would be a good one to start with or do something with. So here we are. We've got the limit as u goes to 0 from the right only of u minus 1 over sine u. Okay, so like I did before, I'm going to break this up. Limit as u, goes to 0 from the right of u minus 1 times 1 over sine u. Now, from the right, I don't know why I put a 0 right there. Oh, wait, there we go. Okay, so now when I plug in 0 for the u, I get negative 1. All right, so now 1 over sine of 0. Well, if you remember from trig, sine of 0 is 0. Sine of 0 degrees is 0. All right. And if you remember the trig graphs, or the squiggly ones, which are the ones that we're going to look at, the sine graph started at 0 and made a little S shape. So that's the sine graph. And so if we look at this, we can see that the limit as 0, as the limit as x goes to 0 is 0. We can plug it in and see. But from the right, which is the one we're doing, from the right, we see that it is positive. And so this would be negative 1 times 1 over positive 0. And so this is infinity. And so our answer will be negative infinity of this particular function. All right, so now this next one. All right, now this one seems a little bit easier. Seems like this one might be one that we haven't done before, but we've done one similar to it. The very first one was done similar to this one, so you might could actually do this one by yourself. So we're going to do the right, we're going to do the left, and then we will come up with our final answer. So the limit as x goes to 2 from the right, of 1 over x minus 2, can't plug in, so it would be 1 over 0. But from the right, I'm plugging in numbers like 3, and this is positive. So it's a positive 0, so this is going to be positive infinity. And now the limit as x goes to 2 from the left, again, I'm going to be plugging in numbers to the left of 0, so like maybe 1, left of 2. Left of 2, not left of 0, and so I'm going to get a negative. It's going to 0, but from the left, it's going there from the negative side. So this is going to give me a 1 over negative 0, which I don't know if that's fancy or formal terminology or whatever, but it works. So that's going to give me a negative infinity. And so again, the question asks, what's the limit for this one? And technically, the limit does not exist because the left and the right don't equal. Now, because this one was so simple, I thought I'd do a little sketch of it. You have graphing calculators. Hopefully you can graph these. Maybe you just remember these. My guess is you don't remember them. And so you're relying on me to kind of give you the graph. But this one's a pretty basic graph. I have a vertical asymptote at 2, which is what these limits are implying. Every single one of these is implying some sort of vertical asymptote. And so we see from the right, we're going to positive infinity. And from the left, we're going to negative infinity. And so we technically don't have a limit. going to this because it's in two different directions. They're unlimited. So that's that. All right, let's look at, do I have another example? I do. I have two more examples to try. Okay, and we're going to see if we can't do these pretty quickly because we don't like these long videos. All right, again, if you're remembering what I've asked you to do when it comes to watching my videos, you should be stopping this video about right now and copying these problems down and trying them all by yourself. When you're finished trying them, then you can turn the video back on and fast forward to the end so you really don't have to listen to me. You can really just watch really, really fast and see if I did anything remotely familiar to what you did and get the right answer. So that's my thought. And if you really screwed it up, then you can listen to me. Here we go. All right. So the limit as x goes to 2, all right, I'm going to do right and left, even though it doesn't ask me to. When I plug it in, I could factor that. I could. I don't know if it would make that much of a difference. All right, so now if I plug it in, I'm going to get 4 plus 8 plus 3. And on the bottom is where it's going to go to 0. But if I'm plugging in from the right, I'm plugging in numbers like 3, plugging in numbers like 4, I'm going to get a positive. And a positive squared is positive. So positive 0. So this is positive infinity. And this is 12, 13, this is 15. So this is going to give me a positive infinity. Now, doing from the left, I'm going to get the exact same thing. And the reason I know that, I'm going to get the exact same thing from the left is because of that right there. That is not going to change this to a negative. I'm not going to get a negative from the left. So from the left, I'm going to get the same thing. So the limit as x approaches 2 from the left is also positive infinity. So my answer for this one is just positive infinity. All right, going a lot faster this time. Okay, so now this last one right here that I have for these examples is the most interesting one, and it's got a radical in it. So we're going to pay very close attention to this. Okay, so we're going to do the left, we're going to do the right, and then we're going to look at the regular. So let's do the left first. The limit approaches -2 from the left. Okay, so it's going to be 7 and then 1 over the square root of x times x plus 2. And now remember, we're dealing with the square root, so we can't take the square root of a negative. So we're dealing with a negative radical issue as well as a 0 in the denominator issue. So let's just be real careful here. That may be what makes this one interesting. All right, so when I plug in a number to the left of -2, go ahead and get me a little sketch going. If I plug in a number to the left of -2, I'm going to plug in a number like -3. So let's see what happens. So if I plug in -3, I'm going to get a negative times a negative, which is a positive. So I get a positive. So I'm getting 1 over a positive number going to 0. All right, so that would be 1 over a positive number going to 0. So that would give me a positive infinity, just like we've done before. All right. The next one is where it gets a little more interesting. Apparently, I didn't give myself enough room. So let's try again. So if I did the limit as x goes to -2 from the right. All right, so again, if I just plug into a number to the right of -2, say -1, let's see what happens to this denominator. So I get a -1 times -1 plus 2, which is the square root of -1 times 1, which is the square root of uh-oh. Nope. You can't take the limit as x approaches 2 from the right because the function is undefined. There is no limit because it's not positive and it's not negative any. It's undefined. This function is undefined over here to the left of 2 at -1. Okay, now it will find definition somewhere else, but right now it's undefined to the left of -2. So this one does not exist. That one does not exist at all. Okay, and so obviously if the first one is infinity, the second one does not exist, well then the third one is automatically does not exist, because obviously the left and the right have to be equal for that one's does not exist, this one's does not exist, and this one is infinity. So, all right, hard stuff, I know. Overall, when it comes to limits, the first thing you do is you try to plug your number in. If it works, awesome. Second thing, if you can't plug it in, can you reduce your fraction? Can you factor it? Can you rationalize it? Can you simplify it? Can you do anything to that situation to make it so that you can plug in? If you can, then do it. Thirdly, if you can't plug it in, again, this is this third option here. I can't plug in the number that I have. So I actually have to analyze it based on what is happening. And we talked about the fact that as that number in the denominator gets smaller and smaller and smaller, the actual value of the fraction overall gets larger and larger. And so we can't plug it in, but as we get closer and closer and closer to 0, this value is getting larger and larger and larger. So those are the first 3 things. Plug it in, yes. Simplify it if you can't plug it in until you can plug it in. Awesome. And then thirdly, if you can't plug it in, then you have to analyze it. Look at the left, look at the right, see if it's going to infinity. All right. Phew, it's just math, y'all. Let's go on and move into section 2-5 on the next video.